Welcome to our physics lesson. We shall handle the topic magnetic effect of an electric current. Okay, so what are we talking about here? This is a Form 2 topic. The prerequisite knowledge is you have already done magnetism. Okay, now I want to break the title into two portions: magnetic effect and then electric current. So what do we need to understand here? If we focus, what do we need to understand? We need to understand that there is electric current. When current flows in a conductor, in a nutshell, in a wire, when current flows in a wire, then we notice some magnetic behavior. We notice magnetic behavior coming from that wire. That is what we call magnetic effect. So we don't have a magnet. We don't have a magnet per se. We have flow of current. But we observe that there is behavior around that wire, and that behavior points to magnetism. Hence the heading, magnetic effect of electric current. Look at this. Now, number one, okay, when current flows, if I may have when current flows, current flow produces effect. When current flows in a wire, but that wire, in a better language, we say current carrying conductor. So when current flows in that wire, we observe some effects. Okay? We observe some effect. We see something happening. What is that effect? Magnetic field. Magnetic field. It's just an example like this. If I have an example here, if this is a wire, this is a wire, okay? And then this is the cardboard. So what happens if the current flows either up or coming down? Whichever way, whether up or down, is immaterial. The core thing is, then it behaves like a magnet. We don't have a magnet. If I may take this as an example of a magnet, we don't have a magnet in this shape. We don't. But instead, it behaves like a magnet. It behaves like a magnet only when current flows. So this conductor behaves like a magnet. Whatever we would carry out the experiment and observe is what we call the effect which we have seen. Okay? Now, let us see. Using this diagram, okay? I've shown you this is an example of a cardboard, and then there is a wire through. Okay? So there is a wire through going. So we have this cell here. This is our cell. This is our switch. So when the switch is on, then current flows. So remember, switch is on, current flow. When current flows here, when you put a compass, the plotting compass, a plotting compass is a small device like this that has a pointer and a tail here. Okay, this, a plotting compass. So when you bring that plotting compass, with respect to this direction of current, that current flows from positive towards negative. So with respect to this direction of flow of current, when you put the plotting compass on top of a cardboard and trace its new position, after you've placed, you mark the head, then you remove. Now you put again the tail now to be on the marker. You will find it giving you this kind of pattern. Okay, this is the kind of pattern you see. This is practical. So this kind of pattern accounts for what we call magnetic lines of force. So if you transfer it again, you will get another pattern, concentric circles. Those are representative of magnetic lines of force. And when there are many, we call it a magnetic field, a region in which magnetic effect is experienced. Okay? A region in which magnetic effect is experienced. Now, this diagram, I have simplified it here. This is the cardboard. This. The red is the wire. Okay? So if there are many, there will be many. There will be many concentric circles. How do you tell their direction? Very important, comes in exam. Okay? The direction of the lines of force which constitute magnetic field can be determined using right hand grip rule. Right hand grip rule. So again, I use my example. This, the current is up. I put my fingers round and then the thumb rests on the direction of current. So if this is the direction of current, then these fingers point in the direction of field. You can check. Just check here. And these fingers. The four fingers will show you the direction of the field. Okay? The thumb must rest on the conductor, or the thumb simply points in the direction of current there. Okay? The direction of the lines of force can be determined using right hand grip rule. Right hand grip rule. So I want you to go and try. Suppose the current, you redraw this, but you change the direction of the current and see if you will get the right thing. Okay? So in this lesson, I have introduced magnetic effect of electric current. In conclusion, when current flows in a current carrying conductor, okay, when current flows in a current carrying conductor, there is an effect. It's not just corona effect or any other. It is magnetic effect. From our magnetism, we had magnetic effect when we had a magnet, when we see a magnet. But this time round, we don't have a magnet, but we still experience magnetic effect. How does it come about? It comes about because of flow of current. Now, next time we're going to see how do we draw magnetic field on a solenoid. Okay, a number of turns together. There are many turns now. Okay, make sure you read in advance. This on a straight conductor, magnetic field drawn on a straight conductor. Next, on a solenoid. I would wish you start knowing how we draw the current in and current out. Current in and current out. If we may focus here now. I want us to focus down here so that we conclude. I've drawn. I'm not a very good person in drawing, but I've tried, okay? So, you can see the thumb rests on a conductor, and this is the direction of the field. So, next time we're going to see what happens if I have a solenoid. A solenoid will be like this. Current coming in, current going out. Current coming in, current going out. So, that is a wire. A wire that comes like this, goes in. A wire comes out, goes in. A wire comes out, goes in. What is important here? You must still go back and understand different ways of making a magnet. Okay? Making a magnet using direct current. When you have a core, a soft iron, and there is a solenoid around it. There is a nail and there are turns wound round a nail. You must know how do you come up with the polarity. It will be very easy to connect. Till then, bye-bye.